Oceans cover over 70% of the Earth's surface and contain 97% of the water on the planet. Salt water from these oceans is also found at various depths throughout the interior of the Earth, trapped there millions of years ago by layers of sediment. During oil and gas production, this naturally occurring salt water is usually found in the same geological formations as the hydrocarbons. On average, 10 barrels of salt water are produced for every barrel of oil. The produced salt water must be disposed of properly. The EPA preferred method for the disposal of produced oil field salt water is through Class II saltwater disposal wells. A disposal well is typically an existing oil or gas well that no longer produces hydrocarbons. This is the only approved method for oil field saltwater disposal, and only wells that meet strict standards for construction, testing, inspection, monitoring, and record-keeping can be classified as Class II disposal wells. This process has been carefully regulated since the 1970s by the EPA through the Underground Injection Control Program, which was established for the protection of underground sources of drinking water. All Class II disposal wells are constructed with multiple surface casing designs for the purpose of eliminating the possibility of the salt water leaking into underground sources of drinking water. The following well casing design is one example of how this is done. Designed to protect drinking water aquifers, surface casing is installed to keep any potential contamination on the surface from entering around the well. Steel casing pipe is cemented into the hole down to at least 100 feet below the water source. In some designs, inside the surface casing is another layer of cement that surrounds a second steel pipe called the long string casing. Inside the long string casing is another steel pipe, the injection tubing. It can also be lined with plastic, adding yet another layer of reinforcement. This multi-layered construction provides an exceptional barrier between the saltwater, freshwater zone and the surrounding geological formations. The annulus, the area between the long string casing and injection tubing, is filled with a pressurized non-corrosive fluid all the way from the surface to just above the disposal zone. The wellbore and protective casing runs through many different layers of rock, many of which have very low permeability. Permeability is the measure of a rock or sediment's flow efficiency. The depth of the well and the number of rock layers that lie between the underground source of drinking water and the disposal zone will vary depending on the local geology. Many of these rock layers have trapped hydrocarbons and salt water underground for hundreds of millions of years. Because water quality diminishes naturally with increased depth, deeper formations are usually chosen for saltwater disposal. These formations generally contain water with very high levels of dissolved solids and salt water, so the disposed salt water is simply being added to areas that already contain similar substances. It is most important to understand that these deeper formations are not potential underground sources of drinking water. At the bottom of the hole, the cement, casing, and area near the wellbore is perforated, creating a pathway for the salt water to be injected into the disposal zone. No more than 100 feet above the uppermost perforation, a packer is installed. Made from special corrosion-resistant rubber, the packer fills the space between the casing and injection tubing. When in position, it expands to firmly hold the injection tubing in place. More importantly, it creates a watertight barrier that prevents salt water from flowing back up to the surface through the annulus and provides the bottom seal for the pressurized annular fluid. At the surface, the well's pressure is monitored. Any slight variation in fluid pressure can indicate a possible compromise, and immediate action will be taken to ensure the well's integrity. When the salt water arrives by truck or pipeline, it is separated for injection into the formation through the disposal well. Any residual oil is held in tanks for later pickup. The salt water is pumped down the wellbore, out through the perforations, and into the saltwater-bearing formation. The low permeability rock above creates a stratigraphic trap or barrier which keeps the saltwater confined to the disposal zone. The scale used in this visualization helps to illustrate the vast separation between the disposal zone and the underground source of drinking water. The depth in this example is approximately 8,900 feet. This is over a half-mile deeper than the deepest part of the Grand Canyon. This great distance is comprised of layer after layer of rock with low to very low permeability. Rock formations so dense and so thick that they have held both saltwater and hydrocarbons in place for hundreds of millions of years. In summary, the layers of rock with low permeability total more overall thickness than the permeable layers, creating a massive barrier between the disposal zone and the underground source of drinking water. Class II saltwater disposal wells provide a reliable and environmentally safe method for disposing of the saltwater recovered during oil and gas production. The fact is, the Earth is saturated with salt water, both on the surface and deep below. Class II disposal wells are simply the best approved method of putting the salt water back where it originated.